All right, great. Thank you, Chris, for that. I'll just sort of reiterate, I've been working with these types of products, the concrete and surface preparation products, since around 2004, so about 20 years. I'm going to apologize up front for my lack of mastery of the Canadian language. And I'm also going to mention at this point that I talk about self-leveling underlayments in this presentation. We use an acronym SLU, so that means self-leveling underlayments. It's in my vernacular, it's the same as saying flowable mortar topping. So basically, materials that are used to flatten and prepare floors for finished flooring.
Because they don't self-level, you have to push them around to get them to do what you want.
That's right. There's a lot of controversy these days about the terminology, which is kind of funny.
That's why we were calling it hydraulic cement underlayment. Which,
yep.
There's so many different parties who will call things differently. If we could all get on the same page with just the terminology, we'd be better off.
Right. So again, I'm going to use in this presentation SLU, but again, we're talking about the same thing here. And the last thing I'll say before I start is that not one size fits all. We're not necessarily prescribing that the things that we're going to be talking about in this presentation you should be doing on all projects. What I will say is that definitely there's projects where these techniques and just this awareness of the gap between Division 3 and Division 9 and the need to do something about it has benefits. So with that said, so the agenda for my talk today, 3 parts. We're going to be talking about just sort of an overview of the problem, defining that problem. I'll talk about a case study and propose one solution that we think will help. So let's define the problem as the concept that it is difficult to make concrete flat. And I put flat in quotes here because I mean really by this smooth enough, ready to install Division 9 finished floor goods. Okay, so rubber floor, sheet vinyl, VCT, engineered wood, the whole ball of wax. So it's difficult to make concrete flat because there's these questions. Who defines what flat means? When is it measured? And how is it measured? So these things come up pretty frequently. So let me dive into this a little bit more deeply. So in Division 3, again, Division 3 is the set of specifications that talk about concrete placement, and Division 9, to oversimplify it, is about floor goods. So one issue is that in Division 3, flatness, for example, is measured by something called F numbers, or floor flatness and floor levelness, 2 different measurements. There is several industry standards that talk about this and define it in detail. I'm not going to get into the technical details about this, but ACI 117, ACI 302, ASTM E1155 is a test method for actually performing the floor flatness test using a device that sort of statistically measures how wavy the floor is. So that's how the concrete contractor is measuring his quality in terms of quote unquote flatness. The floor covering industry typically uses a different method. They're typically using a straight edge, or very frequently using a straight edge. They're reading standards like ASTM F710, which is a standard for resilient floor covering installation. They might be seeing, instead of a floor flatness of say, 50 in Division 3, they're seeing a specification that says, hey, this floor covering should be installed over concrete that is at least 3/6 or no worse than 3/16 inch in 10 or 1/8 inch in 10, etc. Or the flooring manufacturer themselves might specify flatness that's required for their flooring. And in general, concrete floors also have to be smooth to prevent irregularities, etc., from coming up and basically making the aesthetic of the floor goods bad. And they're measured before installation. So this is kind of an important point, these last bullet points, comparing them. The concrete industry, concrete installers are typically measuring these floor flatness numbers, if they're using this, within, say, 72 hours. The Division 9 floor covering people are doing their straight edge test right before installation. So keep that in mind. We talked about FF number and gap under a straight edge. So there's a rough correlation, not a direct correlation, because these are really measuring two different things in a different way, but there's a rough correlation between these F numbers and straight edge tolerances. And for example, Division 3 floor flatness spec of 25, if you look at the graph, it actually sort of corresponds roughly with a 1/4 inch gap in 10 feet straight edge. Or if you go down to the floor flatness of 50, that roughly corresponds to 1/8 inch in 10, which I believe in Canadian is 3 millimeters in 3 millimeters and 3 meters, I believe, right?
Correct.
Okay, I passed my first Canadian English language test. Actually, that's metrics. All right, another problem other than the measurement issue is that concrete flatness can change over time. And some of the subsidiary questions here that should be asked is deflection predictable? And we're talking about deflection in elevated concrete slabs. But also flatness could change with slabs on grade from other effects, settling or curling. And another question about this change over time is who is responsible? So a lot of people have thought about these questions over the years. And what does this deflection look like? Well, it can look like this photograph where you have on the lower right-hand side, you have a concrete slab, which has been recently poured, and you have on the upper right-hand side or diagonal, you have some self-leveling underlayment. And you can visualize on this photo, the high spots in the concrete itself, in the slab. There's some areas that are quite thin, and some areas that are thicker. So that's what this issue looks like when it's been remedied with self-leveling.
Aaron, this is no fault of the concrete pourer.
Absolutely not.
This is just gravity having its way.
That's a very important point. This problem, so deflection may not be predictable to exactly the extent, like how much is it going to happen, but the fact that it will deflect is predictable. So we should keep that in mind.
It's interesting. We got a project we're involved in at the moment. It's around 500,000 square feet of flooring on elevated slabs. And the specification has actually stated no SLU. So $500,000 worth, 500,000 square feet of parent concrete or base slab has to be poured and deliver 3/16 over 10 feet. I don't know how they're going to do it.
And when the floor covering people show up later, there could be a lot of grinding then if there's no SLU involved.
And it won't be in their price.
Right. Who's responsible?
It's going to be a very difficult scenario. At least they're aware of it at these early stages, but they have no budget to add. So either it comes off the bottom line and they add SLU at great cost, or they figure out how they're going to get those parent slabs poured so they stay straight and do not deflect and resist gravity.
Right. I think Keith has his hand up.
Go ahead, Keith.
Yeah, exactly. Actually, and I actually know when this history came about, and it came about when the use of self-leveling concrete, self-consolidating concrete started to become more used. It reduced the numbers of people on the placement crew. There was this whole concept that we could achieve these amazingly flat floors. And it entered into the vocabulary probably about 40 years ago. And we've been so reliant on that ever since. Prior to that, we always had a 2-course pour floor to get that degree of flatness that we were actually looking for on finished substrates. But there was a very definite 2 or 3 year period in history where that transition was, and it's not been the same ever since.
So this was a conversation one day that was, well, how can we save some money? We'll delete the topic.
Bingo. And if we can save money and time in getting the building topped out, everybody's ahead, everybody's happy, right?
So, something interesting to just point out is that all sorts of, different vantage points in this industry, from the concrete people to the floor covering people to the general contracting community, they're all thinking about this. And I just want to show a position statement that some of you may have seen before. It's kind of a famous one, the ASCC position statement number 6, which essentially points out the following things. It says that Division 3 concrete specs measure floor flatness, Division 9 specs measure straight edge gap. The 2 measurements aren't compatible. Floor flatness can change due to curling, etc. And they say, specifically that despite this incompatibility, some specifiers believe that the concrete contractors should be responsible for taking actions when the division floor flatness requirement can't be met. Again, to further complicate this issue, they say contractors seldom receive the Division 9 specs when they're doing their bid. And sometimes the flooring hasn't even been chosen, right, by a designer at the time that the concrete contractors are doing it. So it might be impossible to give them the exact specification of the flooring. Yeah. So ASCC sort of concludes with these highlights at the bottom. They suggest in this position statement number 6 that the owner provide a bid allowance, which you do up front, and it provides an allowance. It enables the owner to compare floor covering bids on an equal basis, because really what happens in these cases is someone is going to be blamed, right? And either the floor covering people eat it, or the GC eats it, or the concrete people eat it. But really, this thing doesn't need to be decided at the end of the project. It should be predictable. So
anticipated at the beginning. Yeah,
right.
Exactly right. I mean, I think ASCC did a great job with that position statement.
Yep. This is a good
simple language.
Simple language. So again, back to the problem. Modern flooring has many requirements, right, that are dependent on the substrate. And we could go into, sort of fire off onto 5 or 6 other 1 hour long webinars on the different requirements that the floor covering people have. But essentially, if you think about the requirements of a nice new hospital, or a high-end, corporate office space, or, even residential, in towers, especially, you have, floors that sort of, this is an exaggerated depiction, but you have a deflecting concrete substrate. And as you work your way up from there, the architects want, the designers want, the tenants, the building owners want, flatness, attractiveness, longevity, durability of that floor. And modern floor goods, you know, they have changed over time. There's more emphasis on things like flatness and moisture. In the tile world, tiles are getting larger. There's, you know, we're seeing some tiles that I don't even know what I don't think they maybe should be called tiles, but they're 10 feet by 10 feet.
Wow.
They're so large that they need special transportation.
And thinner.
Yeah, I was going to say that floor needs to be really flat.
And they're getting thinner as well, those tiles?
And they're getting thinner as well. So there's, you know, very specialized. So again, all comes down back to, you know, that substrate needs to be flat. You need to be thinking about it up front. All right, let's talk about like a theoretical Gantt chart, okay, and compare two methods. We'll call the first method the reactive approach. This is oversimplified, obviously, but it sort of talks about the things that we need to talk about in this discussion. So a typical building project will start with design, right? The architect will design the building in consultation with the developer. Specifications will be developed, contractors will be selected, and usually very early in the building process, the concrete is placed. And then what we'll call just generic construction activities, you know, will be undergone until the project is complete. Typically towards the end of the, you know, hopefully towards the end of the process, the finished floor goods are installed. So, you know, it's kind of important to keep in mind that this happens towards the end because you want to protect them usually. And there's other reasons to do it towards the end too. But in a lot of cases, not every case, but in many cases, the flooring installation gets stalled because of these problems that we were talking about earlier. The floor is not flat enough to meet the specification in Division 9 specs. So the change order process begins. That's the red blocks here. And once that change order process is sort of underway, and oftentimes this is where sometimes fingers can be pointed. Conferences meetings are arranged, and we decide sometimes too late, you know, who's responsible for this flattening that's going to have to be taken place. So then oftentimes at that point, reactive, self-leveling or patching, smoothing of the concrete surface takes place. And it can also be done by other methods, but self-leveling is often used. And then the floor covering installation resumes and finally completes. And then the building is complete.
So essentially that first brown square is the week that the floor cover rejects the slab and there's all hell breaks loose. And go ahead.
Yeah, that's the beginning of the shit show, shall we say.
Exactly. And the floor cover, I think the construction industry just kind of assumes the floor cover will carry the cost to fix the subfloor because it's their subfloor. They know what they need, but it's actually not in the trade scope of work for a floor cover to take on any work beyond the 3/16 over 10 feet or whatever the manufacturer of the floor cover calls for flatness. So he won't carry the costs unless there's a pre-agreed to contract written up where they say, yes, we will bring your Division 3 finished product up to floor covers standards. We'll pay for that. And then there's an agreement in place, money allocated, and off they go. The floor cover can do the work. The concrete guy can do the work. Anybody can do the work, but you got to pay them.
The important thing is somebody has to do the work to get it done right. And so it's just a question of how and when are we making that decision. So a proactive approach that sometimes will be proven to solve these types of problems is to sort of try to eliminate this change order process and the reactive, call it self-leveling or patching, and make it proactive. So really the difference in this, in these two Gantt charts there's a few differences. One is that there's hopefully no change order process, at least as it relates to the flooring installation. And, hopefully up front during the, the specification process, during that development of the specification, we have an opportunity to talk amongst ourselves and get the contractors decide that, well, we're going to maybe let the concrete placement contractors, the concrete contractors, make their structural slabs and not worry so much about floor flatness, and let perhaps, another contractor or the same contractor, doesn't necessarily have to be a different one, but allow for proactive installation of self-leveling, which is one way to solve this problem or to alleviate this problem. And the last thing that I'll point out here is that this can and does end up shortening projects because you're eliminating the confusion at the end, and it definitely can do this. So again, sort of to summarize the concept here of being reactive, you could miss milestones, that the change order process is painful, wasted money, wasted time, and the whole hassle, unnecessary. It's unnecessary, right? Because we all kind of know, everybody really knows that these things can happen. So we've been talking about self-leveling. Again, there's other ways to flatten floors, but we're talking about SLUs in this particular presentation, and it's a method that's been used for years to flatten floors. Very flowable, cementitious material, very similar to concrete, but just very flowable. So this is the typical stack up. You have a deflected slab. You may want to put down an epoxy vapor control, depending on the timing of the project and if it's required, and then the self-leveler goes on top, and that sort of smooths out the waves. Basic, again, this is, self-leveling 101 stuff here, but how do you install self-leveling? Just a little refresher. In this proactive way, we would place the concrete in a new construction project, bull float it maybe to something like a FF of 15, hopefully eliminate some power traveling and avoid curing compounds, because we're then going to survey this now existing slab that's just been placed and bull floated. We're going to place elevation pins so that the self-leveling contractor can place their material using these pins as a guide. And let's say they're maybe a typical project is they're going to put a nominal ½ inch, but that's going to depend on how much the slab has actually deflected. So that's the process in a nutshell. There's a couple different ways of thinking about the proactive. You can do it super early. You can do it a little bit later. You can also put self-leveling down over existing concrete as well. But the early proactive thought process kind of goes like this. So for the market segments like hospitals, medical in general, laboratories, some education, some retail, high-end type of situations where the floor covering is going to have very tight specifications, very stringent specifications. If from the beginning of these projects, the concrete water to cement ratio can be minimized as much as possible, maybe to something like 0.45 or below, that helps with the moisture issues that could occur later. So, reduce that water content if possible. It's going to be poured over metal deck or cast in place. There's other ways too. But in these cases, when it's cast, bull floating or broom finishing. Allow that concrete to reach maybe 70 to 75% of its compressive strength. And again, these numbers kind of depend on a whole bunch of different factors. These are maybe typical for these types of projects. We try to protect that substrate from weather as much as possible. And at the point where we can get the slab up to installation temperatures for the self-leveling, we proceed. Or you can do this proactive method a little bit later. So this is after the interior walls are up. Again, early is like before, it's when you have hopefully maybe a curtain wall around the building, but before you've placed your interior framing. Sort of the proactive, but a little bit later, is after those interior walls are up, and maybe likely before paint. This is typically used in high-rise residential and corporate buildings, office buildings, towers. And again, bull float the concrete, allow it to cure. These are often built from the top. They'll build from the top down with the installation of the self-leveler. But door frames can be installed prior to the self-leveler, and the GC basically provides a clean broom swept floor for the floor covering view. And lastly, you can also install SLU over existing buildings. Some of the same concepts that we've talked about here apply, but not all. And this is just a renovation situation. So, case study. We're going to talk about a project that happened in Issaquah, Washington, or Issaquah, Washington. Not sure how you pronounce that actually. This is a Swedish hospital. The owner was Swedish Medical Services. General contractor was Sellen Construction. Architect Collins Warman out of Seattle. And this was a project that the GC, Sellen, they chose to sort of study the benefits of this proactive installation method. They were also interested in assisting us in creating a white paper. So there is a white paper available on this, which we can make available. So why was Sellen motivated to try this proactive approach at Swedish hospital, and what were their motivations? So these are some things that they told us. So they said, for many years, we've struggled to get flooring installed installed due to moisture content issues and floor flatness issues. They said recently the requirements have become more stringent as the flooring industry has changed and their adhesives and sheet goods. So in the past, the flooring adhesives were more solvent-based and were, I guess, more tolerant to high moisture conditions. And then they went to more low VOC, more water-based style adhesive systems. And at least at the beginning, those were less tolerant. That's changed a little bit over the last several years. This white paper and this study was done in 2010, 2011. So there is some movement forward here, but still we would say floor covering, glues, there's still a lot of humidity maximums out there. So also Sellen said that the impacts to project cost and the schedule, have been enormous in the past for them. And they continue to see an increase in flooring failures in many of their projects. They also said that they wanted to take a proactive role on this project regarding flooring. They didn't want to experience any floor flatness issues or failures as they experienced in the past. And they said, first, we work with the engineers to determine approximately how much deflection to expect for the steel structure after the decks were poured. And in this case, they estimated almost 16 millimeters of average thickness of self-leveler that would be required to fill in the gaps from that deflection. So that's what they're saying there. Sellon said they evaluated a number of options for underlaying to bring them to the specified flatness of FF35. Among those were self-performing cementitious underlayment after the walls were framed, but they came up with, in this particular case, that the most economical solution was to apply the self-leveler directly after or soon after the slab on the deck was poured and prior to framing and the overhead roughing. And they poured the slabs. So I think Sellon self-performed the concrete in this case. So they were a self-performing general contractor who did the concrete themselves. So they poured the slabs, both floated to finish rather than hard troweling, and saved cost in placement of the concrete. So what did this process look like? I'll go through this. So again,
Aaron, let me just back you up there for a minute, just to make clear, you know, if they poured the base slabs and then they're going to immediately apply a topping, they still have to bring the base slabs up to dryness requirements and temperature requirements. So it's not just one after the other because time allows. You do have to have indoor environmental conditions that are conducive to getting that SLU poured according to its instructions, right?
That's correct. Good point, Chris. So I'm not the expert on concrete. There's probably some that are listening to this that are.
Let me just say, one key would be 10 degrees Celsius up here in Canada. That's your parent concrete's temperature before you can start placing SLU, unless the manufacturer says differently.
Yeah, the concrete manufacturer needs to be a part of this conversation. They need to help us with, you know, how quickly can we place the second layer on top of the bolt floated concrete? How long does it take to cure until it's structurally sound enough to do that work? And, you know, in this particular case, I think it was something like 75% of, when it reached 75% of its design compressive strength, which was maybe 5 to 7 days. This was very early, this one, at least in one phase. And, but the experts need to weigh in. They need to, the structural engineers, the architects, we got to get everybody to talk. So in this case, that concrete was placed over a deck. It was bolt floated. So bolt floating sort of looks like this. So you don't see, you know, on this project, you didn't see those helicopters, you didn't see hard troweling. It was, you know, it was a bolt float to about FF15. And they were happy on this particular section that they placed 15,000 square feet before lunch. So quick work. The next process that, again, we allowed and Sellon consulted with their materials experts as to when this next phase could begin. But after that time period, which was relatively short, they shot blasted the surface. This is just to sort of open it up and prepare it for, in this case, moisture mitigation, which they chose to use also as a time compressing technique. So after the shot blasting, there was a survey done. So this is an elevation survey where points on the floor were surveyed for elevation versus the intended benchmark of where the self-leveling was going to top out at. Those measurements were marked. They were also recorded and put onto a heat map. And so this is a technique that's used a lot now by self-leveling installers, flooring installers, where they want to visualize the elevation, the topography of the concrete floor. So with that data, you can put it into software that does this. There's also new devices that can even do like a 3D scan. I think a company called Faro, for example, makes a 3D scanner, which is fairly precise and can create these types of heat maps. So this just, it helps everybody sort of plan out where are the high spots, where would the zero be, where the highest spot, where are the lowest spots in the floor, and helps plan the next step.
Just to be clear, Aaron, the heat maps and they are taken by the general contractor. It's their role to measure the slab before they hand it over to the floor covering trade. Using technology like point cloud survey.
I'm sorry, guys, just to interrupt Chris and Aaron, I just want to let you both know that we're getting to the 140 mark, close to the 140 mark.
Okay, very good. Thank you.
Okay, thank you.
Yep, we're close. We're close to the end of this. So the topography is identified and recorded. This often can happen. This can even happen for reactive projects too. You can use this to sort of see like how bad are we? How bad did we end up without being really prepared for it? But in this case, it was proactive. Also, in this case, moisture mitigation was applied. And very briefly, moisture mitigation in this case was used proactively. You know, it's not cheap to put this stuff down. You need the blasting, and the epoxy itself is not inexpensive. But one thing that it allows, in this case, it allowed for sort of an insurance policy that by the time the floor covering was going to be installed, that there was going to be, if you use this stuff, there's going to be no need for worrying about whether or not the concrete slab is going to be dry enough to install. So this kind of takes that out of the equation, takes the maximum RH tests out of the equation. It mitigates it. These things have very, very low permeance. Afterwards, the elevation pins are placed, and that system is also reprimed in this case, and then finished flooring was installed in the hospital and came out looking very nice. So in this case, and again, these results are available in a white paper that we can make available, but just very briefly, floor flatness, the specification I think was FF35. The actual result initially was something like 94. It did deflect a little bit after that to something in the 80s, but very, very flat. The construction costs for this part of this project was reduced significantly. The construction time was cut significantly from, say, 28 months to 24 months for this phase. And so, time and money are often interchangeable, and in this case, both were appreciated. So again, just to sort of summarize, going early with and being proactive with installing SLU, or at least planning for flattening proactively, it's going to eliminate that wasted time, minimize labor, and you can do this very fast these days and solve a lot of the problems with change orders. I mentioned the white paper. It's available on request. My email is down on the bottom of this slide, agabbott@laticrete.com, or you can contact Chris or Lee at NFCA to get my contact information. Now, the solution, a proposed solution, has to include hopefully something that gets spec writers to take all of these sort of these things into consideration. So NFCA, with the awesome help of and guidance and leadership of Keith, who's on this, proposed a Division 1 specification change, sort of a way of thinking about how to coordinate the different trades to solve these problems. And this is available on the NFCA website. And there is also some educational webinars that have been pre-recorded that are available from YouTube. So at this point, I'll hand it back to Chris to talk a little bit more about what's available here and what that Division 1 spec is.
Okay, let's just exchange my screen for, where are we here?
Do I need to stop
Yeah,
sharing?
if you unshare your screen, Aaron.
Okay.
And I will. There we go. Okay, I'll share my screen. Bear with me. Can you see that?
Yes.
Okay, so that's the homepage of NFCA. This is a great resource for everyone. This is nfca.ca, and you just go to the education tab, down to free resources. Number one, you got a video library, which I'll just take you to very quickly. These are links to all of these videos, which cover everything from what Aaron's going to do, has done today, to gypsum pours, hardwood flooring, concrete in general, lots of stuff, moisture testing. If we go back to the free resources now, I just want to take you to that new concrete specification, which I think, Keith worked incredibly hard on this, and we had a committee of around 10 people on around the table at one point from all corners of the industry. And one of the big things to agree on going in was that we would not move forward on this unless everybody, from the concrete manufacturer down to the floor covering installer and everyone in between, Concrete Placement Association of Canada, et cetera, all agreed that this was a win-win document and made sense. Otherwise, if any one of those entities was losing, it's a fail, because that's not what we wanted. We wanted this to mean something to everybody. General contractors, probably at the top of the list. And so one of the key things that this spec does, there is the free download. It's a dense 38 pages of how to place concrete properly. But what it does, very importantly, is it places this information in Division 1, so that you've got ABC and XYZ contracting, the builders bidding equally, carrying the cost, rather than someone getting the job because they missed $250,000 worth of SLU. That's key and very helpful. If you keep scrolling down, there are the two videos that Keith very kindly recorded, and a ton of information here. It's a template, and we're not being directive about this, obviously. Who are we to be directive? But it's just, we're putting out good information that you can pick through and place into your projects as you see fit, if you're an architect or spec writer on this call. Keith, any comment?
Yeah, I was going to say, it was an amazing group of people to work with, and as you said, it was from the concrete.
Oh, you're breaking up, Keith.
Internet connection. Yeah, so it was brought in. A lot of what is being this spec.
Keith, we cannot understand you, my friend. It's the internet connection is not healthy.
I'm sorry.
That's too bad.
Later.
We'll have to send you some cue cards. But yes, you're right. An amazing group of people, and it was very interesting how we learned. It took us about 6 months to get into the process and understand what our neighbors in this trade were doing, what the next trade that we would hand our responsibility off to actually did. We found out we knew our own stuff very, very well, but not necessarily what our next trade did. So it was a great process. So having delivered that, are there any questions from the audience about what you've heard? I would comment that you had a couple of great photographs, Aaron. One with the two trades that are critical to this whole gap. One being wet concrete finishing, the guy with the bull float, and then in the next slide, I think you had a guy running a shot blasting machine. He would be described as dry concrete finishing. And it's the dry concrete finishing trade that we discovered through our deep dive with this committee. And Keith, I think it was you talking to the Concrete Association that uncovered this aha moment that, you know, there's dry concrete finishing is a trade that actually gears itself, targets itself to pour SLU and to grind high spots.
The
Whereas
biggest aha moment we had.
it was huge, yeah. The wet concrete finishing trade is the one that says, don't call us if it's out by, you know, 3/16 over 10. We don't do that. We get approval at 72 hours so that we can actually give you an invoice and get on with our next job. If we don't have that 72-hour process, we're never going to get paid. And so it just makes sense. But then after that's done, post-pour, post-finish, wet finish, you get the dry concrete trade showing up with all the tools like shot blasters and grinders and scabblers and scarifiers and ready to pour, and they know what they're doing. Floor coverers do not understand concrete, don't want to breathe in the dust, don't have the respirators, don't have anything to do with it unless they're really tooled up to do it. But the dry concrete trade does. And actually, we have members at NFCA who've joined as dry concrete finishers, just to help general contractors know that these services are out there that can be contracted to help them with their projects.
That's right. And Chris, you know, one other thing I'll mention just about the process that I described in this webinar. There are areas in the United States that do, like New York, for example, Boston to some extent, that this technique is used very frequently and very successfully, to the point where, you know, if you're a general contractor like Turner, for example, in New York, you know, and you're building a hospital, it's very likely that you are going to kind of follow the basic concepts in this technique. You're going to assume that self-leveling will be used. For New York, it just works. They tend to not go super early with the self-leveler. They typically allow the concrete to dry out for several months, to the point where the exterior curtain walls are up, and then the self-leveling is done sort of towards the end of the process, after interior walls are up. Certainly this is how they do it for residential condos or apartment towers. The interior walls are up, and then they self-level, and oftentimes because they've waited for several months, maybe a year in some cases, for the concrete to dry, the choice is made not to put the epoxy moisture mitigating material down. It's dry enough by that point. The self-leveler goes down, and in quick succession, the floor covering kind of follows it. And that's how they do it. And there's a lot of GCs who they've grown up doing it that way, and they see it and they do it for every project.
Tremendous. Yes, all makes good sense, and all starts at the beginning of the process. Don't try and squeeze this in when the floor guy shows up at the 11th hour. It's not going to happen.
Yeah, it's just a concept of, I mean, we all know that these things can happen, and why not take, you know, action? It's as you said, Chris, it's often, you know, it's not fair to have two concrete contractors bidding differently. One is bidding with the assumption that they're going to come back and flatten it later or grind later, and another that doesn't have that in their bid. And that can work in a lot of different ways. But if everybody's speaking the same language, it makes the project smoother.
Yeah, well, and to clarify, this concrete specification is targeting general contractors so that they then can talk sense to their concrete sub-trade and their flooring trade. And this download is a free download. All you got to do is click on it and then do what you will. It was a tremendous process, that committee. Anyway, So here we are at a few minutes before the top of the hour. Are there any questions before we let Aaron go? I know, Aaron, you're very busy and traveling as probably you do most of the time. So if
There was one question that came over on the chat from Dennis.
yeah, do you want to
Why
read
do
that out?
Yeah, why do they pour the SLU after the interior partitions are up and not before? So in New York, they do that, I think, primarily due to the fact that they're interested in saving the money on the, well, there's several reasons, but one of them is they want the concrete to dry out before the self-leveler goes down, so they don't have to do the epoxy moisture mitigation, which is expensive. So, and the glues are getting better. So, you know, back in the days where relative humidity maximum was, say, 80% for us, if you were waiting a year, maybe in some cases. But so that's one reason, and it just sort of fits in their schedule. But you can go either way, and every project is a little different. So whatever, I think people that are using project management software like Gantt charts, et cetera, you can compare these things and see what makes sense for your phasing.
Aaron, if I could add something, am I coming through?
Yep.
Yes.
Hi, Joe.
Hi, this is Joe Rizzo with LATICRETE. How are you guys? Great presentation and great sample specs. One of the reasons, particularly in the New York market where it's most frequently done, is that you can maintain a flatness level room to room instead of over a very wide expanse. So whereas certain contractors find that idea abhorrent because they want the entire slab to be contiguous, doing it room by room does afford you the capability of having different levels within a certain variation, nothing crazy. So that is one reason.
Yep. Thank you, Joe.
Absolutely. Yeah, good point. Good point. Okay, well, if there are no other comments from the floor, then we will thank you very much for your attendance. And we'll see you next month. I believe we have an expert coming in from Milliken to talk to us about carpet and all that's going on in that world.